We need to prove that 1 plus cosine theta divided by 1 minus cosine theta, that's equals to cosecant of theta plus cotangent of theta whole squared. We'll begin from the left hand side. We have 1 plus cosine theta divided by 1 minus cosine theta. So what we'll do, we will multiply the numerator and the denominator with 1 plus cosine theta. Now we will simplify it. So 1 plus cosine theta is multiplied to itself 2 times. So we have 1 plus cosine theta whole squared in the numerator. And in the denominator, we have 1 minus cosine theta times 1 plus cosine theta. That's an identity, a minus b times a plus b. So we have a squared minus b squared. That gives us 1 plus cosine theta whole squared. Now what's 1 minus cos squared theta? We know we have a standard identity, sine squared theta plus cosine squared theta, but that's equals to 1, which means sine squared theta will be equivalent to 1 minus cosine squared theta. So in place of 1 minus cosine squared theta, we can replace it with sine squared theta. Now we can rewrite our given expression as 1 plus cosine theta divided by sine theta whole squared, since both the numerator and the denominator are squared. Now we can rewrite this as 1 over sine theta plus cosine over sine theta whole squared. Now 1 over sine theta, that's nothing but the cosecant function, because cosecant function is the reciprocal of the sine function, plus cosine over sine, the ratio is the cotangent function. So we're cotangent of theta whole squared, and this is the expression on the right hand side. Hence we have successfully showed that the left hand side of our equation is equals to the right hand side, hence proved.